what is it? On the 1st of July, NASA detected a mysterious object, 3IATLAS as it's called.
A new interstellar object, 100 times bigger and brighter than 3IATLAS, has been discovered.
Two colossal wanderers, one from the distant Oort cloud,
More data should be collected to uncover the nature of this object.
and another from interstellar space, are arriving within just 3 days of each other. One glows brighter than predicted, the other behaves unlike any comet ever recorded. Coincidence, or something deliberately timed? The sudden arrival of SWAN, C2025 R2R2. In early September 2025, astronomers monitoring NASA's SOHO spacecraft noticed something unexpected in its wide-angle solar camera. A diffuse glow had appeared against the dark background, faint at first, then intensifying night after night. Within days, that blur resolved into the unmistakable signature of a comet, soon designated C2025 R2, SWAN. Most comets slip into the record quietly, small ice rocks cataloged and forgotten. SWAN was different. It brightened rapidly, visible even through amateur telescopes, and stretched what appeared to be a developing tail across the sky. Its orbit was quickly calculated, and the numbers raised eyebrows. This was not a minor visitor. SWAN was on a steep, plunging trajectory that would carry it dangerously close to the sun. Even seasoned astronomers were caught off guard. How had such a luminous object escaped detection until so late? And why was it already releasing so much material at such a great distance? The discovery prompted urgency. If this newcomer was larger or more volatile than expected, it could provide a rare chance to study pristine material from the outer reaches of the solar system. But for others watching, the timing was stranger still. SWAN was not arriving alone. Another cosmic traveler, even rarer and far more puzzling, was already on course for its own near-sun passage. Within weeks, their paths would overlap in ways that seemed almost scripted. A corridor of giants. Astronomy is full of coincidences, but some seem too well timed to ignore. Just as SWAN blazed into view, astronomers were already tracking another traveler, 3IATLAS, only the third confirmed interstellar object ever recorded. Unlike SWAN, which most likely originated in the distant Oort cloud, 3IATLAS was a true outsider, a body flung across unimaginable gulfs of space before drifting into our solar system. The strange part was not simply that both objects were on approach. It was that their closest passages to the sun would occur within days of each other. On October 17th, 3IATLAS would sweep past perihelion. Only 3 days later, SWAN would follow, cutting its own path close to the star. Their trajectories were vastly different. One retrograde, the other prograde, with entry vectors separated by more than 100 degrees. By every rule of orbital mechanics, the odds of two such wanderers arriving so nearly together are vanishingly small. For those who study celestial statistics, the event felt like lightning striking twice in the same spot. Some dismissed it as cosmic chance, the kind of coincidence that occurs when billions of icy remnants drift through space. Others, more conspiratorial, wondered if the timing pointed to a deeper pattern or even intent. Whatever the truth, one fact was inescapable. For the first time in human history, Earth was about to witness an interstellar visitor and a near-sun giant sharing the same celestial stage, and the instruments watching them were about to record something no one expected. Inside the data. Numbers can sometimes be more unsettling than images. As orbital data for SWAN accumulated, calculations showed a near-parabolic path, one that suggested it might be making its first ever journey from the Oort cloud into the inner solar system. Its eccentricity hovered at the edge of 1, its inclination tilted steeply against the planetary plane. The message was clear. This was no routine comet looping back for another pass. It was a stranger, newly arrived from the solar system's frozen frontier. Yet it was the subtler measurements that began to stir debate. SWAN's trajectory refused to fit cleanly with pure gravitational models. Small deviations, non-gravitational accelerations, hinted at something more than simple ice sublimation. Comets often release gas jets that act like tiny thrusters, nudging their paths ever so slightly. But the pattern here was uneven, almost step-like, as though pulses of force were pushing against the void. Photometry brought its own surprises. Even before perihelion, Swan brightened in fits and starts rather than following the smooth curve most comets display. A sudden outburst in late October lit up detectors, expanding its coma and stretching a faint, uneven tail. Spectroscopic analysis revealed the usual traces, Cn, C, 2, O, H, but also suggested unusually strong releases of volatiles. These were not exotic enough to declare the object artificial, yet strange enough to keep questions alive. Taken together, the data painted a picture of a body that was familiar and unfamiliar at once. Astronomers could explain each anomaly in conventional terms, but only with difficulty. Meanwhile, a second set of numbers, belonging to the interstellar visitor ATLAS, was about to challenge explanations even further. If Swan's deviations looked like whispers, Atlas's data would soon sound like a shout. The mystery of 3IATLAS. If Swan unsettled astronomers, 3IATLAS confounded them. From the moment its path was traced, it was clear this object did not belong here. Its velocity was too high to be bound by the sun, its eccentricity greater than 1. This was not a solar system native, but an interstellar messenger, a fragment of some long-distance system, hurled across light years before slipping into our observational reach. Interstellar objects are so rare that only 2 had ever been confirmed before: Oumuamua in 2017 and 2I/Borisov in 2019. Atlas became the third, and almost immediately it began to misbehave. Its spectrum did not match the familiar fingerprints of water-rich comets. Instead, nickel signatures dominated, while the balance of gases leaned heavily toward carbon dioxide, far greater than astronomers expected. This was not a frozen snowball, but something harder, more metallic, more alien to solar system norms. Then came the accelerations. Careful tracking revealed that ATLAS was not coasting smoothly. Instead, its velocity changed in abrupt increments, as though nudged by unseen forces. Outgassing could explain gradual drifts, but not sharp pulses. Some observers likened it to a spacecraft firing maneuvering thrusters. Others cautioned that unusual jet geometry could mimic such effects. Whatever the explanation, the power implied was staggering, on scales measured in gigawatts if it truly were thrust. Each new dataset seemed to add another contradiction. The object behaved like a comet, but with a chemical mix unlike comets we know. Its path shifted like a machine adjusting course, yet telescopes saw no obvious source of propulsion. In Atlas, the cosmos had delivered a paradox, a natural body that refused to act naturally, arriving just as Swan was preparing to ignite the skies. Swan as a fortress comet? As attention turned back to Swan, its behavior only added to the unease. Observers noted fluctuations in brightness that did not follow the smooth rhythms of a typical comet. Instead, they resembled bursts, brief surges of light, then sudden calms, almost like pulses. In orbital calculations, these bursts coincided with subtle changes in trajectory, reinforcing the sense that something was pushing the object in fits and starts. Theories multiplied quickly. Some speculated that Swan's nucleus was sheathed in an unusually reflective metallic crust, a hull of nickel or cobalt glinting under the sun. The idea of a protective skin led to wilder suggestions that the coma enveloping it might function as a kind of plasma shield, absorbing solar radiation and dispersing it in controlled flashes. To others, these were nothing more than imaginative stories layered over poorly understood physics. But the imagery stuck. The notion of Swan as a fortress drifting through space, armored and deliberate. Calculations of the implied forces pushed the debate even further. If the accelerations were not from random jets of gas, but from something coordinated, the energy required would be immense, measured in thousands of gigawatts. That is power on the scale of entire civilizations, not of a fragile ball of ice. The suggestion was provocative. Either the models were missing something fundamental, or Swan was not what it appeared to be. Most planetary scientists urge caution. Comets are notoriously unpredictable, capable of fragmenting, flaring, or fading without warning. Swan's oddities could all be explained, at least in principle, by exotic but natural chemistry. Yet the timing, the scale, and the echoes of artificial precision meant that, for many outside official circles, Swan became more than a comet. It became a riddle. The blackout window. As both Swan and Atlas drew closer to the Sun, a different kind of mystery emerged. Between October 8th and 18th, the geometry of their orbits placed them almost directly behind the Sun from Earth's perspective. For professional observatories, this meant silence. Instruments that could normally track their progress were blinded by solar glare, cutting the flow of data during the most critical days of their approach. For scientists, such a blackout was a predictable limitation of celestial mechanics, an unavoidable gap in observation. Yet outside the official channels, the absence of information bred speculation. Amateur astronomers reported difficulties accessing even partial updates from agencies. Some began to whisper that restrictions were in place, that space agencies and defense networks had quietly discouraged reporting until the objects re-emerged from the Sun's glare. Whether those suspicions held any truth or not, the effect was the same. The world watched and waited, knowing that two extraordinary visitors were hidden in plain sight, just beyond reach of our instruments. When they emerged from conjunction, the first images and measurements would either calm the speculation or inflame it further. Until then, mystery filled the silence. Why it matters. To some, Swan and ATLAS are simply celestial curiosities, frozen relics from distant realms passing briefly through our skies. But to others, they represent something more profound. These two bodies appeared together not just as objects of study, but as symbols of how little we understand about the universe surrounding us. Their timing alone invites questions that science struggles to answer, while their anomalies hint at processes still beyond our models. For astronomers, the significance lies in data. Swan offers a chance to examine material that may have lain untouched since the solar system's birth. Atlas, with its interstellar trajectory, carries the chemistry of another star's nursery. Each fragment of light, each spectral line, may rewrite what we think we know about cosmic origins. Yet the mystery extends beyond equations. Humanity has always looked to the sky for meaning, weaving stories from patterns of light. The sudden arrival of two strange wanderers recalls those ancient instincts, stirring awe and unease in equal measure. Whether natural or something more, their passage reminds us that the heavens still hold secrets, and that sometimes the most important discoveries are those that refuse to be explained. As Swan and Atlas fade back into the dark, they leave behind more questions than answers. Perhaps they were only icy relics, perhaps something more. What endures is the reminder that the universe still writes mysteries far greater than our understanding.